Good morning, good afternoon, good evening. Welcome to this instance of the Antrea community meeting, which incidentally is also the last community meeting for the year 2023. We finished this year with a very interesting meeting where we are going to discuss the future roadmap for the Antrea project, which will be presented by Antonin. And then in the remaining time, we will have a conversation about supporting egress with IPs from a VLAN subnet, and that will be driven by Chan. So I think we can get started. So Antonin, please go ahead.
Yes, thanks, Salvatore. Let me see if I can share my screen. All right, I'm really not gonna take too long. Maybe let me open that file instead. Here we go. So as part of a bit of context, maybe as part of our annual review process with the CNCF, as you know, Antrea has a CNCF project, and even as a sandbox project, every year we go through a review process where we update the community and the TOC as to our activities during the last year, and what are our focus or plans for the upcoming year. And so as part of this review, the CNCF suggested that we update our roadmap because we had not updated it for a couple of months. And even though, of course, I didn't get into the technical details, a lot of the information in the roadmap was actually stale because some things that we had already implemented were still listed in the previous roadmap. And so I took the action item to update the roadmap, and most of these updates are removing stuff that we have already implemented or stuff that we are no longer prioritizing in Antrea. Increase the accuracy and be more specific for some other items. And yeah, I also, after discussing it with the other maintainers, I also added a couple of new items that we may be focusing on the medium or long term. And so just maybe I'll go through a few highlights since we have some time. I added Antrea v2 in the roadmap. I don't think we've decided yet if it was going to be Antrea 1.15 or Antrea 1.16 that was going to be promoted to version 2, but I think it's safe to say that the release is coming in 2024. So that gives us some time, but this is definitely something we're going to do in the upcoming year. Kubernetes node security, this is something that was already on the roadmap. If you recall, I think a couple of meetings ago, Chan presented an implementation proposal for this using IP tables. So also, I think it's fair to say that this is something which is going to be coming to Antrea next year. Quality of life improvements for installation and upgrade. This is kind of like a new quote-unquote bullet point in the roadmap that for things that we're planning to do either in the short term or the long term. Something we are going to do in the short term that somebody is already working on is separation of the container image for the agent and controller. Because currently someone who's deploying Antrea to a very large cluster, of course, maybe they have their own registry, maybe they do some caching of the images, but by default, the agent image is going to be pulled by every node in the cluster, which can take some time, and that can slow down installation, and that can slow down upgrades. If you're on a slow network or if the registry is pretty slow, you can notice that it can take like even on a small cluster, it can take a bit of time for Antrea to finish deploying. So by removing the controller from that image, we're going to make the agent image smaller. And by only adding the controller the controller image and removing everything which is specific to the agent, things like suricata and so on. We're also going to have a very small controller image, and that's going to help ensure that during an upgrade, the controller is updated before the agents, which is a recommended way of actually doing an Antrea upgrade. And there are a couple of other things for CNI migration, and Chan had like an idea that we could like support Antrea installation and upgrade using a dedicated command in NCTL, which is something that other CLIs are doing it as well. And this way, NCTL could kind of like help ensure an optimal upgrade where the Antrea components are upgraded in the right order. And don't hesitate to interrupt me if you have questions or comments. Core networking features. Of course, there is the VLAN tagging for egress, which Chan is going to discuss right after my presentation here. And so we're going to find out more about this. And also, we've decided to add BGP there, at least for the long term. I don't think we have immediate plans in the near future to add BGP support, but I think that's definitely something we consider to be in scope of Antrea, the ability for the agent to do BGP peering and exchange routes with like underlay routers, for example. Because that's something that for which we've had quite a few user requests, as far as I know. Windows support improvements, that's something that was already there before. But I kind of like try to make it like more specific and more up to date in this PR. And I know that I am personally working on improving the user documentation to kind of like streamline it and make sure that the recommended installation method is like clear and unambiguous, and it comes first in the documentation. More robust FQDN support. You guys probably have noticed that over the last couple of releases, I think starting like around 1.10 potentially, we've had like a succession of bug fixes and improvements to improve the FQDN support in Antrea network policy. So the ability to specify domain names in policy roles to filter the traffic based on the domain name. We think this is like a pretty cool feature in Antrea, which is not too common in the ecosystem. And so it's really in our best interest to try to make this feature as attractive and as stable as possible. And again, we've worked towards that, but maybe we could consider doing like more testing at scales that would be representative of an actual production deployment. Implementation of new upstream network APIs, that's something that Yang and others in the community are working on. Of course, Yang is involved upstream in the design of those APIs, but he's also leading the implementation of those APIs in Antrea. And so the upstream work is still evolving, and those APIs are maturing. And so our plan is to keep tracking those changes and keep making sure that the Antrea implementation closely follows what's going on upstream. The ability to do packet capture, this is a new addition to this roadmap. Previously, we had a lot of like troubleshooting items in the roadmap, and most in the previous version, I mean, and most of those items have already been implemented, trace flow and so on. And so this is the one item that I think we have pending here, and that we're still working on. This is something that we talked about in the community meeting a couple of months ago, if I recall correctly. Multi-network support for pods in Antrea. I mean, you may recall that I think it was at the last community meeting we discussed some user feature requests specific to multi-network. And by multi-network here, I'm talking about what's traditionally done with Multus in Kubernetes, and what we are implementing in Antrea behind the secondary network feature gate. And so we're planning to continue this work and see if we can, again, improve usability with some user-facing documentation and also add support for new use cases. I'm going to try to go a bit faster. L7 security policy. Currently, we support a limited set of protocols, HTTP and more recently TLS. And so there are other protocols that we could consider supporting in L7 policies, for example, DNS and so on. Multi-cluster networking, you know that there has been a very active feature in Antrea since version 1.7. I think most of the functionalities that we wanted to implement as part of multi-cluster have been already implemented, whether it's like service load balancing or security with multi-cluster policies. I think that we can probably like improve usability and stability, and maybe in the near future, maybe after the V2 release for Antrea, we could consider graduating it to beta potentially. Let me skip the next one. It's nothing new, but I think we have some ongoing work to facilitate benchmarking the performance of Antrea by simulating a large number of agents. And the last two items on the list are kind of like new items. Investigate better integration of Antrea with service meshes. That's something that was suggested by Tom in an issue a while back. This is something that came up during KubeCon in Chicago last month. If you want to have like more information about it, you can take a look at this issue that Tom opened. It's a pretty interesting topic in my opinion. And finally, investigate multiple replicas for the Antrea controller. Once again, this is something that Chen brought up, and he presented some ideas, if I recall correctly, a couple of months ago at during a community meeting. So yeah, potentially supporting multiple replicas for the controller. Today we only have one. That could like open up the way to some interesting features, or rather interesting capabilities, whether it's for horizontal scaling, even though today our observation is that a single replica of the controller can scale pretty well. So whether it's about horizontal scaling or HA, to have a faster failover. I think today in recent Antrea versions, the failover of the controller is around the 1 minute mark, if I recall correctly. So potentially, which is still pretty good, but potentially with like a separate replica in standby mode, we could go under 1 minute and get closer to a few seconds. So here's the updated roadmap. Feel free to ask questions now, or feel free to take a look at my PR and comment. Otherwise, well, it's a Christmas break soon, so maybe I can wait until after the Christmas break to merge it. Give some time for comments.
All right. Do we have questions, comments, suggestions for the roadmap? Okay, I can only see that I like it. I don't have anything else to add, so thanks, Antonin, for sharing it. And we can move to the next topic, which is egress IP from a VLAN subnet. Egress with IP from a VLAN subnet. So, Chan, please go ahead.
Okay, thank you, Salvatore. Let me share my screen. I made a presentation about this. I hope my screen is visible.
Yes, we can see it.
Okay. Okay. This is a proposal for supporting egress to use IP from a VLAN subnet. And before talk about the implementation and the proposal, let's take a look at what's the current problem. And if you this is a typical egress, how typical egress works today. And as you can see from the IPs, this is a egress IP and this is a node IP. The way it works mainly relies on the routes already installed in the host network, and to leverage the routes, currently we just ask users to allocate egress IPs from the same subnet of the node network. So if you take a look at these egress IPs, they fall into the same subnet as the primary IP of the node. So that when we need to SNet the traffic, we don't need to have anything specific for these egress IPs. We could just change the source IP and leverage the default route to forward it to the gateway of the node network. So the problem is that some users don't like sharing egress IPs with node IPs due to some restrictions, or just want to avoid to using the same IPs. Typically, if we just use IPs from another subnet, technically it could also work, but this may not be the best practice, because even we use IPs from another subnet, the route is the same, and when the IP package try to be forwarded to an external address, we could still use this route to route the package to the default gateway. Just need to ensure that the default gateway has a route to this to this network to route back the reply traffic. A better solution is to use VLAN segmentation to segment the two subnets, only keeping one subnet per VLAN, and this could also probably reduce the broadcast domain, I think, and it also a better, I think, network best practice. So this is what we could do, and next I will talk about how we could implement it to tag the traffic when it leaves the node, and how we receive the reply traffic when it's tagged with the VLAN ID. And first, to make it possible, we need to let user to be able to express the intention to use another subnet and share us the information of the subnet. So first, we need to make an API change to the existing external IP pool to make user input this information, and the subnet info field will be used for that. It has 3 fields. The first one, gateway, will indicate the gateway IP of the subnet. As you should notice that if we use a different subnet and tagging the traffic, we can no longer use the original default gateway. So the gateway of the new subnet should be provided. And to figure out what address are directly connected to the subnet, we also need to know the prefix length of the subnet, so that we don't just route everything, route every packet to the gateway. And for the directly connected endpoints, we can access them directly without going through the gateway. And we also need to know the VLAN tag of the subnet, though it's not must-have. As I mentioned, even there is no VLAN tagging, we could just share the same LAN for multiple subnets, though it's not the best practice. So with this information, we can know that what gateway we should use, what tag we should tag the outgoing traffic and expect the reply traffic should have which tag, and the IP address, the mask, the network mask of the IP address. And when designing this API change, I referred to the current IP pool API. It's kind of like this, and I didn't strictly follow it because I consider some drawbacks in the current design, and given that the current IP pool API is in alpha, while the external IP pool is in beta. So I want to use a format, a struct that makes more sense. And I also want to discuss the proposal here. As you can see from the left side, if we follow IP pool design, we need to append subnet info specific fields to every IP range. And if using the current proposed approach, we need a separate struct to include all subnet information for this IP pool, and all IP ranges should share the same subnet info. The reason I choose the right is because there are a few reasons. The first is the first one may introduce confusing usage to users. If you look at the IP ranges, each IP range could have it's possible that they don't share anything in common, and we can put a different CIDR and put different prefix lengths and VLAN into it. So I think to users, they may not know that in which case they should use a single external IP pool to include all IPs for the whole cluster, or they should use a separate IP pool for each subnet. This is like that in other APIs like service or network policies, and we could also like just make the service the current service API or the network policy API a slice, and could all keep appending more resources into the same one. I think this is not the current Kubernetes API style. The second is it's more complicated to implement this kind of struct because first is after an IP is allocated from the pool, we don't know which IP range it is allocated from, and we don't know its gateway and prefix length VLAN it should be associated with. If this list could be very long, every time we want to know the associated subnet info, we must iterate all IP ranges to find that information. And in some case, we need to do something when the external IP pool changes with a list of IP ranges and different gateway and prefix lengths. Every time a single field is changed in this IP pool, it may cause a much larger scope of changes to the whole system because we don't know which IPs will be affected by this IP pool, because you could have everything allocated from the same pool, and it's not easy to identify what changes we need to reconcile based on the IP pool update. Yeah. And the third reason is its redundancy in when user want to input multiple ranges that sharing the same subnet, because user could first allocate some IPs from this subnet and then append then some more in the same subnet. In this proposal, it could have they would need to improve the same information about the subnet multiple times. So eventually, I prefer this struct and make external IP pool the unit of a subnet, and every IP ranges in the same IP pool should have the same subnet info. If you have any comments about this design, feel free to propose. And
yeah, go ahead, sorry. No really comment from me from the API. I mean, the second proposal obviously makes more sense. That's all.
Okay, thank you. And after changing API, we have know that what the user want to use, what subnet they want to use. So we could, based on that information, to change the data plane. And I explored several options to tag the egress traffic. However, the only feasible way I found is using policy routing and the VLAN subinterface. I could explain how it could work. That currently, without a subnet info, we will have a dummy interface. We call it Antrea -egress 0, and use it to hold the egress IPs we allocated to the node. And but it's it is dummy because the traffic will not really go through this device. It will just go through the external device. We don't actually assign the IPs to the external device is to better manage the assigned IPs, because once we assign the IPs to this interface, we don't know which were assigned by us on restart, and we don't know which IPs we could safely delete from the IP from this link. So we use another device to hold it. And when the IP pool is with a subnet and has a VLAN provided, we can no longer assign the IPs to this device because the RP filter of Linux doesn't allow a device to receive traffic when it has no address, even we set it to loose mode, because it's hard-coded. It is the implementation hard-code that there must be an IP address on this device. And due to the nature of VLAN subinterface, the traffic will eventually arrive at this subinterface, and that's the only way that the system could untag the VLAN tag of the incoming traffic automatically. So we have to assign the IPs to the actual subinterface. The good news is that since we could create the subinterface and we assume that the user doesn't create the interface in advance, so it's safely to delete IPs when it is no longer needed. And yeah, as
Hey,
you can see that, yeah. Please go ahead.
Quick question, and I don't know if it makes sense, but if the user brings a physical interface ENS 160 down and then back up, does that impact the VLAN interfaces at all, or not?
You mean set it down, this external device? Yeah, I think because this is the logical interface of the parent interface. If the parent is down, I don't think there is any traffic can be received by this sub interface.
Okay, but it doesn't impact configuration, right?
Yeah, it doesn't impact configuration. Okay. But we assume this one, we only create sub interface of the primary interface. So if this is done, I think the whole node is unreachable after that.
Yeah.
Yeah. But its configuration is independent. But
Okay.
yeah, it relies on its parent interface. When we create such interface, we will bring it up and we will change some configuration like RP filter, and we will also assign IPs from this subnet to this interface. So
and if the main interface is managed by a network manager, can it impact the sub interface that we create, or you don't think so?
I haven't tried it, but I think it shouldn't affect it, because we have created an Antrea egress 0 interface for a long time, and I don't see any case in any case they erase IPs from this device. I think they should be the same, even though this is an actual interface, not a dummy one. But I don't think the network managers will care about whether it's dummy or VLAN subnet, sub interface. Yeah,
makes sense. Thanks.
So egress IP will be assigned to this sub interface, which is kind of a VLAN tagged, like Antrea AXT dot kind of.
Okay. Yes. As I mentioned, I tried to assign the IPs to the same dummy interface and only install routes to route the traffic out from this device. But unfortunately, the RP filter drops the reverse packets because no IP address is on this one. Yeah. So the first step is that based on the subnet information, we create a corresponding VLAN sub-interface and assign the IPs from this subnet to it. The second step is that based on the subnet information, we will create a separate routing table. We allocate 101 to 120 as the egress tables. So there are 20 route tables, and means that we could support at most 20 different subnets in a cluster. We could also support more, but I feel that in a cluster, it's unlikely you will need more than 20 different subnets as egress IPs. And the maximum route tables a node can support is 253, I think. So to reserve tables for other purpose, in the first implementation, I only allocated 20. And if this is the first subnet, it will use 101 table. And in this table, we install two routes. The first, this one is used to route the traffic, the traffic to destinations that are directly connected to the VLAN and locally. And the second one, the first one is used to route other destinations. We need to route the packets while the gateway of the subnet. And as you can see from this field, both routes use the the VLAN subinterface as the outgoing device, so that the Linux networking system will be responsible for tagging the traffic with with the VLAN ID we specified in the IP link device. And to make the egress traffic associated with this subnet look up this IP root table, we also need to install one IP rule for each egress IP. You know, we have already marked the egress traffic in OpenWSwitch when we classify it as an egress traffic. We classify it as egress traffic. For example, the first egress IP will get the packet mark 1, and in the networking system, it will look up this IP rule, and when the packet has this mark, it will look up this table, and then eventually be routed to this default gateway and sent over this device. And when it's sent over this device, it will physically send over this external device and with the VLAN tag. This is how the transmit path goes. And this slides explained it in more details. The packet is marked by OS, and then is sent to this gateway device, and it will be processed by the routing system. And because it has the mark, it will look up the custom route table and be routed to this device. And after the routing is processed, it will go over the IP table's post-routing chain to be asynaptic, and eventually it will be sent over from this device with the tag. And similarly, the incoming traffic will also first arrive at this external device. Because it has a tag, it will be sent to the logical interface and be untagged. And so we expect untagged packets on this device, and just like other egress case, it will then be undetected to its original port IP and forwarded to its source port. Yeah. I want to also mention there's one limitation that may affect the performance of using subnet VLAN. This is because if there are only few egress IPs located from subnet, and if one node doesn't have such egress IP, for example, it doesn't have this one, we still forward for inter-node egress traffic, because let's say port 3 wants to talk to external, while an egress IP on node 1, because it doesn't have the sub interface, it will have to send its egress traffic to node 1 first. And because it has only the primary IP, it will have to be forwarded by the router. But this is a problem. This may be a problem for an external router, but it's not a problem for a distributed router, because anyway, the router will forward traffic between the two nodes. So in this release, I didn't do anything to make this more efficient, assuming that the user case should be very limited, and perhaps we could assume that this will not cause real problem with a distributed router. And the current action plan is that I have already created a PR for the proposed implementation, and I think Antony has reviewed it the first round. And the feature will be gated by egress separate subnet feature gate, and it will be disabled by default in the coming release. And then next I will do a demo about this feature. I have deployed a kind cluster with the implemented code, and as you can see, I have a client deployed in the default namespace, and I also run a server to return the client IP, so we know whether the egress take effects. If we just use script to test the egress IP, and when there is no egress configured, it's supposed to use the node IP as the source IP. And now we could create some external IP pool, and let's create 3 ones. The first is associated with a subnet using VLAN tag 20. The second one is using VLAN tag 10, and the last one doesn't have VLAN information. And let's create all of them. Now we could create egress to use IP from the IP pools. I will first create the. I will first make it use the IPs from the subnet without VLAN. And if we run the command again, we should expect that it will use the egress IP as the source IP, as indicated by the return value. And when we capture the traffic on the gateway side, we could see that the traffic is without VLAN tag. Now let's change the egress to get IPs from the pool with a VLAN ID. Let's first use 10. Now it will get IPs from the VLAN 10 pool, and we could test the traffic again. Yeah, it's supposed to use this egress IP, but more importantly, we want to show that now it has the VLAN tag. As you can see from the packet capture on the server side, when it access external, it's now tagged with the VLAN tag. And if we take a look at the host network, now it will has a VLAN sub interface, which is sub interface of the primary interface, and it will have the egress IP assigned to it. And there will also be IP rule to make traffic tagged with this mark to look up this table, and this table will use this interface as the outgoing device. Yeah, this is how it works. And now let's change the egress to use another VLAN pool. Now it get this IP 20, and let's try to access the server again. It now gets return value indicate it use the correct egress IP, and from the server side, packet capture, we can see that after we change the egress IP pool, it will now be tagged with this new tag, and on the in the network system of the egress node, the original device has been removed because currently there is no IP address allocated to it, and we created a separate subnet subinterface for the new VLAN, and the mark is reused and the table is reused because the original has been released, but the content of the root table has changed to use the new device and the new gateway. Yeah. And if we just delete everything, everything related to the VLAN should be deleted, and the device has also be deleted. Yeah, that's the demo, and that's also all information I want to share with you. If there's any questions, I could answer now.
Have a question.
Yeah,
How many VLAN sub-interface can be created on the same parent? Is there a limit?
I didn't check that, but that limit may be much more sufficient. Because the real limit we currently face is the root table limit. I think it could at least create 253 sub-interface, I guess, because the VLAN and could span from 1 to 4,000, right? But the table
Yes.
ID can only span from 1 to 253. Yeah. So the real limit is the root table.
Okay. Got it.
But note that we need only one sub-interface for one subnet. So unless you need more than 20 subnets in this cluster, the current implementation should be enough. The most possible subnets we can support is 253.
Understood. Thanks.
Chen, if it's limited by the row table, does that mean the maximum VLAN we support is also 253?
Yeah, it's one the root table and the subnet is one mapping. Yeah.
Mm-hmm.
Regardless, you have, but you if actually if you have different you make different subnets using the same VLAN ID, it will further reduce possible VLANs you can have, because we create one root table for each different subnet. Even they share some VLAN ID, we don't create it for a VLAN ID.
Okay, thanks. One more question is regarding the VLAN ID. It can be picked by the user randomly, or we have to support that on the node physical network, on the lane network.
The current implementation is only on Antrea side, User still needs to, if user want to use a VLAN ID, they must ensure that the underlying physical network, the switch, support that tag. It cannot be just selected randomly. Yeah. If they have a specified one VLAN ID and it doesn't allow the VLAN ID to be transmitted in the network, it will be dropped by the switch. So the two sides need to keep aligned.
Okay, thanks.
I have another question related to the subnets. It appears that, according to the previous introduction, it appears that we use a mark to mark which traffic goes to which subnet and the relevant route tables. Does that imply that we can have overlapped IP subnet in different egress or in different external IP pool as long as they have different VLANs?
Sorry, can you repeat the question?
I mean, if I have VLAN 1 and VLAN 2 and VLAN 3, can I have the same subnet on the two VLANs?
I think no. When you use the same subnet for different VLANs, it already breaks how network works. I think for the returning traffic, you don't even know which VLAN it should send to, right? On the router side, when you want to route a packet to Antrea cluster.
In the router, maybe there are two different routers actually, and then the two different routers will do a SNAT, and then they use different SNAT IPs. But in the downlink side, maybe the subnet can be overlapped, but actually they are two different VLANs.
But from the router's uplink perspective, how that? Oh, I see. You mean when they further go external, they assign to another IP?
Yes. Because
I don't think about this case. Yeah.
Yeah. I think this is not a very realistic use case, just a bit curious, because I found that we use a mark locally. So in theory, it appears that we can have overlapped subnets in different VLANs. But just curious, not ask. Thanks.
Yeah. I haven't thought about the case. When implementing egress features, I already assumed that there shouldn't be overlapping IPs.
Yeah. So we have validations on the subnets IDs, right?
When creating IP pools, I think we haven't implemented such validation. Yeah, but yeah, it's good to improve in the future. Yeah.
Understood. Thanks.
Chen, I have one more question regarding you say that will be marked with specific ID. What kind of ID is it assigned by the egress feature or?
Oh yeah, yes. This is the original implementation, and we also leverage it in this new feature. This is because the MAC is because we need to tell the IP tables is the real component, or net filter is the real component to SNAT traffic. We need to tell net filter which source IP it should use for our packet, outgoing packet. So when we want to we allocate egress one mark for each egress IP, and we will mark the packet in OS pipeline. Then when it goes through the host network, it will be SNATed. Currently, we support at most 255 marks, meaning 255 different egress IP can be assigned to a single node.
Okay, got it. Thanks.
If there's no more questions, I think that's it. Thank you everyone for joining the meeting and your questions.
Hey, Salvatore? Salvatore is saying that his microphone is not working anymore. So, well, I'll close the meeting then. Thanks everyone for joining this last meeting of year 2023. We had a great year together, and I'm sure 2024 is going to be another great year for Antrea. Oh, yeah. Salvatore, I was closing the meeting for you.
No worries. Go ahead, finish the meeting. Let's finish this year in a different style with you closing the meeting.
All right. Well, I was saying that we had a great year 2023, and I'm sure we're gonna have a great year 2024 together. So happy holidays, everyone. Enjoy the break if you're taking one, and we'll see you in 2 weeks then.
All right. Have a good one, and talk to you in 2 weeks' time.
Thank you. Bye.
Thank you.
Bye-bye.
Thanks. Bye.